Okay, am I audible? Okay, so we are discussing about your types of flow. Okay, types of channel flow. So first, we have already discussed about your steady flow and unsteady flow, and it is the based on variation with time. Okay, that's steady flow and unsteady flow. Then we have discussed based on variation with space, that is your uniform flow and non-uniform flow. Again, non-uniform flow, we have three types. One is your gradually varied flow, one is your rapidly varied flow, and another one is your spatially varied flow. Okay, so again, and the third conditions we have based on gravity, force of gravity, that is your subcritical flow, critical flow, and supercritical flow. So all these flows are related to your Froude number. For subcritical, it's less than one. For critical flow, it's Froude number one, and for supercritical, it's always greater than one. Okay. Okay. Froude number is always remember it is a ratio between your inertia force to gravity force. Okay. So next is based on viscous force. So these things you have already studied. We are not going to discuss again. Your laminar flow, turbulent flow, those things you have already studied. Okay, we are not going to waste time or discussing this thing again and again. Okay, Reynolds number. Okay, your supercritical, subcritical, and your critical flow based on your Froude number, and your laminar, turbulent, and transitional flow is based on your Reynolds number. Okay, those things you have already studied. The next one is your based on your coordinate system phase, that is 1D, 2D, or 3D. And then next is based on density. Density, see, we consider the density of water to be constant, but this is an assumption. We cannot say the density of water is always same. Okay, so that's why we have two types. One is homogeneous flow, where your density is constant, and another one where density takes place due to different density of two liquids. Okay, so one is in same and one is in different. Okay. Next, few things you need to remember, or you already know that hydraulic radius is area by weighted perimeter. Okay. Those why I'm identifying those things, because you are going to use to solve numericals. Those equations R equal to A by P, that is hydraulic radius, R equal to A by P, area by weighted perimeter. Hydraulic depth, that we have already discussed, that area by top width. Okay. Then another one important term is K value, that is discharged by root over bed slope. SB is nothing but your bed slope. SB is your nothing but your bed slope. Do you remember what is Manning's equation? Manning's equation is used to find out the velocity. V equal to 1 by n r to the power 2 by 3 SB to the power half. Okay, this is the Manning's equation. What is n? N is your roughness coefficient. R is hydraulic radius, that is R equal to area by weighted perimeter. Okay, And SB, we have already discussed, it is a bed slope or slope of the channel. Okay. Okay. Next, the very important topic is your velocity distribution in a channel. Okay. This is very important. See, suppose if you want to draw a top view, okay, or show you here. Is it visible?
So,
Okay. See, you can see here in this Google Earth image, the top view of your river, Kulsi River, that I have already shown you that the basin diagram. So this is your top view of the river. Okay, you see here, this yellow line is the width of the river. Okay, so what happened? In some location in the river, it is very difficult to reach. Okay, and to measure the width of the channel. So we use some satellite data to find out what will be the width of the river in those particular locations where is very difficult to reach. Okay, so here you can see this is the width of the channel, that yellow line. Okay, this width of the channel for the Kulsi river at different locations. Okay, you can see this is towards the downstream, how the people is staying near the river. Okay, and during flood time this whole things is flooded. Okay, this whole thing is underwater. Okay, so if you see here, if you see in this picture, this is the top view. Okay, if you see, if you draw a section here, if you draw a section here, and then you draw the cross section, it will be like this. Okay, so this is the level of water. Okay, so when you have a section like this, which is irregular in shape, now the question is where you are going to measure velocity. Okay, where is what will be the velocity of flow in that particular channel section. See, we all know when you consider the bottom of the channel, suppose this is your boundary of the channel. This is your boundary of the channel. Okay, this is the boundary of the channel, and this is your bottom. This is your bottom of the channel. So when you move from bottom to towards the free surface, this is your free surface. This is your free surface. When you move from bottom to the free surface, your velocity is not same. As you can see here at the bottom level, your friction is more with the bottom of the channel. Okay, so here what we consider, the bottom of the channel, we consider the velocity is zero. Okay, and from zero when we move upward, it increasing. Okay, but when we come to the free surface, as in the free surface there is also flow of air, and there is an interaction between the flow of water and flow of air, it seems that your velocity at the surface is got reduced. Okay, this is at the surface. So when you move from bottom of the channel to the free surface, your velocity changes in this way. Okay, we consider velocity at the bottom is zero, though it is not zero, but we consider it to be zero theoretically. And then when you go upward, if this is your y value, depth of flow, from bottom of the channel, if you go towards the free surface, then your velocity is increases, and when it reaches the surface, due to the interaction between the flow of water and the flow of air, your velocity is again reduced a bit. Okay, so that's why when you talk about to measure velocity is very difficult, where we are going to measure the velocity as it is not constant. Okay, similarly, if you move from left to right, if you move to left to right, so definitely because of this friction with the boundary, again the velocity near the boundary of the channel is less than the middle portion. So you can see the velocity is also varying in this way and in this way also. So it is very difficult to measure velocity in a natural channel. So what we need to do in natural channel, so that's why we need to study about the distribution of velocity in an open channel. Okay, suppose you have taken one cross section here. What we are going to do, what we are going to do, suppose this is your channel section, this is the boundary of the channel, this is the boundary of the channel. So what we do, suppose this length, the width of the river we can measure. Okay, suppose here it's 68.83. Okay, or you can consider it 70. Okay, so then we divide the whole length into number of sections, say about 10 meter. Okay, so 10 meter section with it. Okay, then we divide the whole section into some section depending on the width we considered. Suppose this is 70 meter, we can consider 1 meter section also, we can consider 10 meter section also. It depends on you. If you take more section, if you take 1 meter, it will be section will be more. So if you take more section, then it will be more accurate. Okay, so it depends on you. Okay, how you are going to divide. So here if it is 70 meter whole width of the channel, we are going to divide into 10. Okay, for an example, so 10 meter we have taken section. Okay, okay, 10 meter. Okay, 6 7, it will be another one if we consider it is be 60. Okay, 60 meter. Okay, 1 2 3 4 5 6. Now we are going to measure the depth of flow. Here y1, y2, y3, y4, and y5. Okay, okay, so we are going to find out the area of this will be the area. How we are going to consider this is a triangular section. Okay, so what we do, as this is an irregular shape. Okay, so we don't have any defined calculation to find out the area of an irregular shape. So what we do, we divide into number of section, and the first and last one we consider it to be triangular section, and all the others we are going to consider as trapezoidal section. Okay, and we find out the area. Suppose this is area 1, area 2, area 3, area 4, area 5, and area 6, and so on. Okay, we find out the area, and then velocity. But we have studied the velocity at the bottom of the channel is zero and it's moving, increasing, and when it reaches to the top or surface, it again decreases. So this is the surface of the water. So what people say, if you take average of two, that means at 0.2% of y or at 0.8% of y at two section, and then you take average. So they are saying that to find out the average velocity, you have to find out the velocity of two section, that is point 0.2 and then point 0.8, and you take average of both. Okay, then you will get the average velocity for a particular section. Okay, so what you have to do, you have to use this equation for each area. For suppose here, for this particular area, you have to find out the average velocity by using this concept. Okay, you have to find out velocity at point 2. You have to use some instrument to find out the velocity. Our most widely used is your current meter that you have already studied in third semester. Okay, so use current meter and find out the velocity at 0.2 and 0.8, and you take average, then you will get the average velocity for section 1 or for this section. Okay, then similarly you can find out the section of that particular next section, then section 3, section 4, and so on. Okay, and then you add all, you will get the average velocity for the whole cross section. Okay, this is how you're going to find out the velocity. Okay, as your velocity is not constant for a particular section, it's varying when you move from bottom of the channel to the surface of the channel, and it also varying when you move from left to right or right to left. Okay, so to find out the average velocity, this is the equation we are going to use. Okay, so what happened last year, in the beginning of this year, okay, when we are doing the project with your 8th semester students, okay, they they uh, they need to find out the velocity in that Kulsi river, and then we don't have that instrument called current meter. So what we did, suppose this is a top view of the river. We consider one section, okay, and then we consider another section. We measure the distance between the two, okay. Then we use a piece of paper. As soon as we drop here, we start our time, or you can say stopwatch. Okay, and we have measured how much time it takes the piece of paper to travel from section 1 to section 2. That is the time. Then we find out the velocity. Velocity we know meter per second. So it will be x by t1. But if you see logically, this velocity give you the surface velocity. Okay, and we all know when we move from the bottom of the channel to the surface of the channel, then our velocity changes. So this is not the average velocity we are talking of. The average velocity is, you need to find out the velocity at 0.2, you need to find out the velocity at point 0.8, and you have to take average, then only you will get the average velocity. What we are getting here, this is your surface velocity. So in such situation, you have to use this equation to find out the average velocity. That average velocity is equal to, you have to multiply it by coefficient k with the surface velocity, because to find the surface velocity is easier than the average velocity, because you need instrument to measure the velocity exactly at point 2 and exactly at point 0.8. Okay, So then for pool C, we have used one coefficient that is already we have found in the literature that two scientists from IIT Roorkee, they did a experiment and they found that one expression for Brahmaputra River. We have used that equation. So this is not the way what we have did, but because you don't have the instrument, we are using this process. Okay. Otherwise, it's always preferable to go with this expression to find out the average velocity. You find out the velocity at point 2 and point 8 and you take the average, that will give you the average velocity. Okay, you can see here. You can see here in this diagram. Okay, this is your bottom of the channel. This is your bottom of the channel. When it goes up, you can see your velocity increases. Your velocity increases, and when it reaches the top of the channel or the top of the channel, or you can say free surface, your velocity got reduced. Okay, is expected to reach here, but due to interaction between the flow of air and water, your velocity comes here. Okay, it's expected to reach here, but due to that interaction, your velocity got reduced and reached here at the surface. Okay, so we always need to find out 0.2 and 0.8% of y. Okay, 0.2% of y. Y is the depth of flow, total depth of flow. Okay, we have to find out the velocity at that location and here and here. Then we have to take average v 0.2 plus v 0.8 divided by 2. Okay? You will get the average velocity. Some scientists also says that you can, if you directly take the velocity at 0.6%, you will get directly the average value. But later on, various experiments they have performed, and it came that this is more appropriate, this equation. Okay, and see, if you are going for any competitive exam, this equation is very common. How to calculate the average velocity in a natural river or in an open channel. So your answer is this. You have to find out the velocity at 2 point, at is 0.2%, and one is at 0.8. Then you have to take average. Okay. If you see, these things are nothing but your control line. Control not for elevation, for velocity. This line belongs to 0.5 meter per second, 0.678. If you move towards the from the what we have already discussed, from the boundary from left to right or right to left, if you move, okay, if you move near the boundary, it's always less, that is 0.5. Okay, so at middle it's always high, that is 0.85 or 0.8. Okay, so this is an example how the velocity varies. Even when you move from top to bottom or left to right or right to left, your velocity changes. Okay, near the boundary it's always less, and in the middle portion it's always high, but at the surface again it got reduced due to interaction between your flow of water and flow of air. Okay, so this is all about your velocity distribution in a channel section, or you can say in an open channel. Okay, okay. Okay, this is what we are talking about. So when you have a cross section of a channel, when you have a cross section of a channel, we are going to divide the cross section into number of section. Okay, into number of sections. Suppose this is your 60 meter, width of the river is 60 meter, then we have to divide into 10 meter. Say it is 10 meter is not your standard one, it depends on you. You can take 5 meter also, 1 meter also. The more number of section you will take, the more number of section you will take, the more accurate value you are going to get. Okay, so what we have to do, you have to divide the number of section. Okay, we are going to consider this first section and last section as a triangular. Okay, to find the area, we use the triangular action, that is equation, that is half into base into altitude, to find out this area of the triangular portion. Okay, and then for rectangular, sorry, this is we are going to consider as a trapezoidal. Okay, sum of the parallel sides divided by 2 multiplied by your vertical distance. Okay, so we find out the area, all the area, and then for each section we are going to find out the velocity by using that same equation. We are going to find out velocity at two location, and then we are going to take average for each one. Okay, suppose for v1 average, that is average velocity for first section, we will take v1 at 0.2, v1 at 0.8, then we have, yeah, we are going to take average. Okay, then whatever the velocity we are going to get, that will be for only for section 1. Okay, then we are going to find out q1 is equal to area 1 multiplied by v1 average. Okay, then you will get q1. Then similarly you are going to find out q2, q3, q4 and so on. Then you are going to add all the discharge to find out the total discharge of that particular channel section. Okay, so this is how you can find out your discharge in that particular section, or velocity, or a cross sectional area. Okay, so here it's already given. This is nothing but this is your q1, this is your q2, this is your q3, that is a3 into v3. Okay, this is q3 and so on. So for total discharge for that particular section, you have to add all. Okay, and then you can find out the average velocity. Then you can find out the average velocity. Do you have any doubts regarding this? You can ask me now. All students are requested to give their enrollment ID, okay, in the chat box for attendance. If you people don't have any questions, then we will move forward to the next topic. So if you have any questions, you can unmute yourself and you can ask. Okay, Stephanie, which equation? Bates-Slope equation. Bates-Slope equation. You're talking about Manning's equation? Can you unmute yourself and you can speak? Stephanie? Let's see the question. Yeah, I am not getting. If you are asking about the Manning's equation, that average velocity, we can also use this equation 1 by n r to the power 2 by 3 sb to the power half. Okay, rate slope is nothing but Stephanie, you are not audible.
Oh, sir, can you hear me now?
Yes, yes, I can hear.
Oh, sir, can you explain again the bed slope? Like, it was too fast. I can't catch up.
Which one? Which one? For average
The
velocity
Manning's
or how
equation.
to find out bed slope? Which one you are talking about?
How to find out bed slope before average velocity, sir?
Okay, how to find bed slope? It's very important questions. Okay, I think you people have already learned about this how to calculate bed slope, but still I am going to explain you. Okay, how to find out bed slope. Okay, forget about it. When you consider a channel, when you consider a river, it's coming from upstream to the downstream. Okay, we are considering one river. Okay, so now we need to find out the slope of the channel. Okay, so what we are going to do, we are going to take two sections. We find out the RL. Okay, RL we have already studied in survey. Okay, so we will be finding RL
Mm,
at particular location. Okay, suppose this is your location one and this is your location two. Okay, so we are going to join these two line by a straight line. Suppose here it's your 100-meter RL, and here if you consider it's 50. Suppose, okay, okay, then
yes.
we are going to find out this angle. That will be your slope. That is tan theta. Okay, tan theta is nothing but your RL. So what is tan theta? Perpendicular by base. Okay, tan theta is perpendicular by base. What is perpendicular distance? This distance. So here RL is 50. So here RL is, sorry, here RL is 100. Here RL is 50. So this distance will be your 50 meter. Understood, na, Stephanie?
Yes, sir.
Ah. Then we are going to measure this distance from section 1 and section 2. What is the particular distance? And we consider it as a base. Suppose 100 meter. Then when you find out the slope, that is tan theta, then it will be 50 by 100. That will give you approximate slope of that particular channel. So now, if I want to say why you have considered 100 meter, you can ask me. So it always depends. See, natural channel, when you're talking about river, is each and every 1 meter or 2 meter, you can say they are changing their slope. Okay, so it is very difficult. Okay, it is very difficult to find out the accurate values. Okay, in natural channel, if you consider a man-made channel or artificial channel, there you can find out the accurately because their cross section is fixed. Or there, if you design a canal, those things you are going to study again in irrigation, we beforehand we calculate the slope and we provide that slope for installation of that canal. Okay, but when you're talking about river, because it's a natural, so it is very difficult to find out accurately. So this is the method which we commonly used. Okay, say this 100 meter, if you take 50 meter, then you will get here. Actually, it depends on at what location you want to find out the bed slope. Okay, so wherever you want to find out the bed slope, you find two section, one at upstream and one at downstream, or that particular location where you want to find out. Then you measure the length. Okay, suppose here, so you one in Kulsi River, what we did in Kulsi River, what we did, we find out two slope. One is the slope of the whole channel. Means from here, what is the elevation is here, elevation is here, and what elevation is in the downstream. Okay, then we have taken two elevations, and then you cannot take the vertical distance. Okay, you have to take this whole length of the river. Okay, so that will give you appropriate, or you can say not accurate, almost accurate values. Okay, so now if we find out the slope between here, okay, if we need to calculate the slope here at this location, okay, so whatever slope we have calculated here, that is from beginning and at the end of the river. Okay, so if we find out here, want to find out slopes, so then we are going to take two section. One definitely is here, and one we should have to take upstream. Okay, so it depends on you, you take here or here, doesn't matter. Okay, then you take RL of here, you take RL of this portion where you require to find out the slope. Okay, then you find use that calculations, you take tan theta. Okay, tan theta is give you the slope, so you will get the appropriate one, not the exact one. Okay, okay,
Mm. Okay, sir.
so any other
Thank you, sir.
doubts? See, in next chapter also we have a chapter called design of channel. Okay, so in design of channel we are going to again design artificial channel, where these things will be more proper, how we are going to find out the slope, how we find out the discharge, and then how we are going to design that particular man-made. Definitely when we are going to design, those are artificial channel or man-made channel. Okay, so because our irrigation canal, or if you say drainage system, those are artificial, and those we are going to design those channels. Okay, so in the chapter we are going to discuss only to design, how to design and how to implement. Okay, okay, explain against the base slope equation. Okay, okay, how to find out the area. Okay, the next question is how to find out the area. Okay, let me stop sharing this. Okay, see, if you have a river, if you, this is your top view. Okay, when you see the river in this way, you always imagine it is in a top view. Okay, so if you take a cross section, okay, if you take a cross section and if you draw the cross section, it will be look like this, it will look like this. Okay, so this is a plain surface, but actually if you draw, it will be somewhat like this. Okay, you cannot say it's a plain surface. If you draw a natural channel, it will be look like this. Okay, at any shape. It's a irregular shape. We don't have a plain surface. It will be look like this. Okay. So how to find out the cross-sectional area of such channel is first you have to find out the top width. T. What is the top width? Suppose the top width of this particular channel is 60 meter. Just an example, okay? If the top width is 60 meter, then what we are going to do? We consider number of section, okay? Or suppose if we consider a 10-meter section, that means we are going to divide the whole section into 10 meter. Okay. So from here, if we start 10 meter, what we do, we take a boat. Okay, we take a boat. As a 60 meter, you cannot travel, right? We will take a boat, and then we measure from the what do you say, bank of the river. We measure 10 meter. Okay, 10 meter. Then when we reach 10 meter, we use a long bamboo. Okay, and we insert in the river to measure the depth here, and we will mark at y1. Okay, understood? Or you can use cross staff also. It depends, it's up to you. Okay, you have to measure the depth. Okay, so what we do, we take a boat, we travel 10 meter from the bank of the river. Then as soon as we reach 10 meter, we measure our first depth. Okay, y1. Then again from here, again we travel 10 meter using the same boat. Then again we measure the next depth. Okay, next depth y2. So see, when we draw, we just draw this section and we find out the mathematically. Okay, but when in the field, what we do, we first 10 meter we measure the depth and we write it down in the note. Okay, then again we travel 10 meter, then again we measure the depth after 10 meter, then again we travel again 10, another 10 meter, we measure the third depth, then again we travel 10 meter from here, then we will measure the next depth, and so on. Okay, okay. So from the field, what data we are going to get? All the depth. Okay, all the depth we are going to get. Now we need to find out the area. So as this is an irregular shape, okay, what we consider this is a plane. Okay, we consider it's a triangle. It's a triangular section. Okay, it's a triangular section. Then we use the equation of area, half into base. It's already 10 meter. We consider that 10 meter multiplied by whatever the depth we have calculated, we will substitute here. Okay, and that will give us the area of that particular section, that first section. Okay, for second section, as this is a irregular, we consider it to be a straight line. Okay, and we consider it is a trapezoidal, that is two sides are parallel. Okay, then we can consider it is a trapezoidal. So we find out the area of that second section is sum of the parallel sides. So one side is y1, one side is y2. So those readings we have already measured in the field. So y1 plus y2 divided by 2 multiplied by again your vertical distance between the two. Okay, that is your 10 meter. So this is how you can find out the y2. Similarly, you can find out y3, y4, and so on. And the last section again, we are going to consider as a triangular, that is half into base into altitude. Okay. So once you calculate all the areas, to get the total cross-sectional area, we add on. So your total area will be A1, your total area will be A1 plus A2 plus and so on till the last area. Okay, you find out separately all the sections areas and then you add all, which is give you approximate cross sectional area. Okay, in the natural channel. Okay, so this is how you can find out the area of a natural river. I think it's almost time. Okay, it's we have another 2 to 3 minutes. So if you have another questions, you can ask me. Okay, is it clear? Because see, if those things you have not understood, it will be very difficult for you guys to solve problems. Okay, so if you want, we can discuss these things again and again. Okay, till it is clear to you. Okay, so in next class, if you want, I can repeat these things again. Okay, or if you have any questions, or in the next class, the very beginning, you ask me those questions, then we are going to discuss those questions, and then we proceed. So any other questions you want to ask? Okay, if you people have no questions, then we are going to end our lecture here today.